Yes, sir. Node is a point of connection, sir.
Very good. Point of connection of any
Any
branches.
branches, sir.
Branch
Branch means a
branch
single
means
element, sir. It may be a voltage
very good.
resistor, sir.
Very good. Very good. What is your name?
Mohanadipti, sir.
Dipti. Very nice. Very good. అట్లనే follow అవ్వండి. Now next one is resistance. After completion of resistance inductor resistance, we'll go for these laws. Let me finish this resistance. Later I will stop here. See, resistance is a property of a material. It is a property of material, or let us take a conductor. Property of any material or conductor, which is a restriction of current flow, or which opposes a flow of what is that property? Which opposes the flow of electrons. It is just like a friction. If you take a mechanical one, it is a friction which opposes, and a bus is moving on a particular road. There is a friction which opposes, or if any high amount of the wind is flowing, it will opposes the motion of which one, a bus or car. Likewise, if you take a copper conductor, there are so many electrons are there. There are so many electrons, and if you apply a battery with the help of the wires, a 5 volts battery, then these electrons are moving in a loop. Now you can understand, this is called a loop pump. In a loop, while these electrons are traveling in a loop, due to this property of a material, some opposition when these electrons are flowing, inside this conductor, wire and this conductor, some opposition is taking place due to that property of a material. That property which opposes the flow of electrons or charges is known as a resistance. Okay, so increasing resistance will reduce the flow of current. I will discuss this point after discussing the Ohm's law here. And here, this is a voltage. The flow of electrons is nothing but a current I. And the property of this material which opposes the flow of electrons is known as a resistance. And that property can be modeled as a resistor, which is symbolically represented as this. This is the what? Symbolic representation of a resistor, and which is denoted by R. R is denoted for resistance. Okay, so finally, the conductor property can be modeled as a resistance, or this is a voltage V plus and minus, current I is flowing. This is known as a electrical circuit, we know. So what do you mean by resistance here? It is a restriction or opposition to the current flow. Current is what? A flow of electrons. Okay. Now, electrical resistance is measured in ohms. In the name of scientist, the units for the resistance is ohms. Okay, and they are abbreviated by the letter R. Resistance is represented as R, and the symbolic representation is units for ohm. Like if you take a property of resistance as a resistor, that resistance equal to 5. We can write 5 ohms or 5 like this symbol. This is omega symbol. You can write 5 ohm or this. like 1 ampere current, 5 volts, you can write 5 ohms. Next, another definition here, which opposes the flow of current or flow of electrons. Units are ohms, and it is measured by ohm meter, and the device which is used to measure the resistance is ohm meter. Current is measured by ammeter, and voltage is measured by voltmeter, and resistance is measured by ohm meter and connected across it. Suppose I don't know the resistance of a particular material, then I can connect a ohm meter between these terminals A and B, which will measure the resistance. The reading will shown here, like 10 ohms, 5 ohms, like that. Based on the property of the material, that will be measured by the ohm meter. And it also depends upon the type of the material and the area of material and the length of the material also, because R equal to design formula rho L by A, where L is the length of the material and A is the cross-sectional area, rho is the resistivity, specific resistivity. It depends on these particle parameters. So it depends on the material, that is rho. Rho is different for different materials, and area and length. And it produces heat when the current flow through it. I will give you a best example for this. Heater. Might have seen the heater like this. And there is a wire which is used to connect to the switchboard. Yeah, it is a material, right? It is a what? A material which is having a property of resistance. When you connect a heater to a switchboard, the current is flowing through this element, this material, then heat will be developed. The heat will be developed. So the best example to understand this point is it produces a heat, the material, the property of a resistor. So it produces heat when current is flow through it. Fixed and variable resistors are present. You can change the resistance. See here. Resistivity. I already said that R equal to rho L by A. See, if you take a copper conductor, this is a copper conductor. The length of the copper conductor is L. Length of the copper conductor is L. And this is a cross-sectional area. What do you mean by cross-sectional area? If you cut that conductor, you can see this cross-section. Imagine 3-dimensional. This is a cross-sectional area A. And material with a resistivity. This is specific resistivity. The equivalent of a conductor can be represented as this symbolic representation of the R. If you apply a voltage, current will flow through this. Now, the resistivity of the common materials like this here, a silver material, copper material, aluminum, gold, all these are material. Each material having its specific resistivity. And 1.64 into 10 to the power of -8 ohm meter. Resistivity units are ohm meter. And it is used as a conductor. Copper, this specific resistivity is this much. It is used as a conductor. Aluminum is used as a gold is used as a conductor. Due to the high cost, we are not using gold as a conductor. Copper or aluminum. Okay. Now carbon, germanium, silicon, these are common under semiconductors. Paper, mica, glass, and Teflon, these are common under insulators. Because of the resistance, if you observe the resistance of the insulator, చూడండి ఎంత resistance ఉంది చూడండి. this much of resistance is there, very, very high resistance, 10 to the power of 10 ohm meter per meter, this much of resistance. Okay, there is a high amount of opposition is there, so that current will not flow, so that those are known as the insulators. Okay, so this is the symbolic representation of a resistance, and this is a resistor. So with this we finished the resistance also. This is the symbolic representation of resistance. It is measured in ohm. Okay, it is a property of material which opposes the flow of electrons. So, in concluding here, today we discussed about current, the flow of electrons, which is denoted as the current I. Units are amperes. Yeah. Next, we discussed about the voltage. V. Units are volts. How to define a voltage? Work done to move a charge. Mathematical expression is I equal to dq by dt, and mathematical expression is V. Work done per charge. Next, we discussed about the power. P. Time rate of energy, that is dW by dt. Units are watts. Later, we discussed about node, branch, loop. Node is an elemental connection, and branch is an element. Node is an interconnection of the branches. Loop is a possible combination of closed path in a circuit. Later, we discussed about the resistance. Okay, it is a property of a material which opposes the flow of electrons, and it is measured in ohms. Symbolic representation is this, and a letter R is used to represent the resistance of a particular element. So these are the specific resistances. Sometimes they will give length of the conductor and area of the conductor, and you want to calculate R value for a particular copper or silver. Then you have to substitute this value, 1.72 into 10 to the power of -8. So these are the basic things which are used to understand the Ohm's law. Once if you thorough with these definitions and these concepts, Ohm's law is very simple. So in next class, we'll discuss about the Ohm's law, KCL, and